Phantom voltage readings at terminals occur when a meter detects a voltage that is not capable of delivering meaningful current because of stray coupling, poor contacts, or instrument interaction. Phantom voltages most commonly arise from capacitive or inductive coupling between live conductors and adjacent open conductors. Long runs of cable lying parallel can transfer a small alternating current through capacitance that a high-impedance digital multimeter will register as full-line voltage, even though the circuit cannot supply current. Another frequent source is poor connection integrity. Oxidized terminals, loose set screws, or partial conductor contact raise contact resistance and produce unstable readings that shift with probe pressure. Meter-related factors also matter. A high-input impedance meter shows phantom voltages much more readily than a low-impedance instrument because it draws negligible current and therefore does not collapse induced charges. To test whether a reading is real, place a known resistive load across the terminal such as a 1 kΩ 2-watt resistor or switch to a low-impedance voltage tester. If the voltage collapses or falls to near zero, the original reading was phantom. For safe troubleshooting, always de-energize circuits and verify absence of voltage with two different methods, a low-impedance tester and a reliable non-contact indicator, then confirm continuity and tight mechanical connections after repairs. When inspecting terminations, clean corrosion with a contact brush, retighten to manufacturer torque recommendations, and replace damaged wiring or connectors to restore stable, measurable voltage that can deliver current. 3 common mistakes lead technicians and homeowners to misinterpret phantom readings. First, relying solely on a high-input impedance digital multimeter without a comparative low-impedance test, which can be solved by carrying or borrowing a low-impedance meter or using a calibrated resistive load to verify the reading. Second, failing to secure or clean connections, producing intermittent contact and fluctuating measurements. Remedy this by de-energizing, inspecting, cleaning, and torquing terminals to specifications and replacing compromised components. Third, ignoring induced voltage from nearby energized conductors and assuming a fault on the circuit under test. Identify this by isolating the conductor, rerouting if possible, or testing with the adjacent circuits de-energized to determine whether coupling is the cause. BigHomeProjects.com connects homeowners with local contractors who can diagnose and fix electrical issues, including phantom voltage and poor terminations. The platform also helps contractors find job leads and build trust through verified reviews and clear project scopes.